So today we'll learn about Haber process. Haber process is an essential industry process to produce ammonia. So first of all, we'll learn about a brief summary of the Haber process. The Haber process is actually a combination of nitrogen from the air with nitrogen derived mainly from natural gas such as methane into ammonia. So we can see that the reaction is reversible and the production of ammonia is actually exothermic. So from the equation itself, we can see the mixture of nitrogen and hydrogen going to in the reactor is in the ratio of volume of 1 volume of nitrogen to 3 volume of hydrogen gas. And it is a reversible reaction where the product of the reaction, which is ammonia, can themselves react to produce back the original reactant, which is your nitrogen gas and hydrogen gas. So here's a very simple diagram for the Haber process. Some notes on the condition. The first one I would like to explain is the catalyst. First of all, the catalyst is actually slightly more complicated than pure ion. It also has potassium hydroxide added to it as a promoter. A promoter is actually a substance that will increase its efficiency. The second one will be the pressure. The pressure can be different from one manufacturing plant to another, but you have to remember the pressure is always high. However, you can't go wrong in an exam quoting 200 atm. So for this, recycling of the H2 and nitrogen is very important. At each pass of the gases through the reactor, only about 15% of the nitrogen and hydrogen will convert to ammonia. So by continuing recycling of the unreacted nitrogen and hydrogen, the overall conversion is about 98%. So some important key facts that I need you all to understand and to remember, which is hydrogen and nitrogen is mixed in a ratio of 3:1. Because the reaction is reversible, not all the nitrogen and hydrogen will convert to ammonia. This explains why only 98% were produced in the factories. The ammonia forms as a gas but cool and liquefy in the condenser. So hydrogen and nitrogen which do not react are passed through the system again, so they are not wasted.